All right, we are going to get started with our next post-break session. Hopefully everyone is fed and caffeinated and ready to go, because get your brain in gear. I think you are going to love this. I got in touch with Pepijn at some point during the year, and we started talking about doing some security content at MacTech, and the timing worked out. He said, great, I think we're going to have some things to talk about, and boy, do they have some things to talk about. So I'm not even going to take up any more time. Please give a big welcome to Pepijn, Bruienne.
You got it. Nice.
And Rich Smith from
Much
Duo
easier.
Security.
Easy one.
Excellent. Well, thank you for turning up. I've got a confession to make. This is actually my first Apple conference. So forgive me if I make any mistakes, but I'm normally at hacking conferences. My background is much more in offensive research, breaking things, and so I'm normally at the Black Hats and the DEF CONs. So this is my Apple cherry. So I'm very pleased to be here. I'm glad that you turned up. Different to Pepijn, who is an Apple veteran.
Yeah, at this point. Everyone, so I'm an R&D engineer these days at Duo Labs, aspiring R&D and reverse engineering person at this point. At some point, I'll get even better at it, hopefully. Recovering Mac admin, as you're supposed to call yourself. And I maintain a couple of open source software projects, minor compared to some of the other folks here, but hopefully useful to some people. And I'm also co-host of the Mac Admins podcast. Who here listens to the podcast?
Nice.
Nice. So you don't have to spend money to do a listener survey. You can just do it this way.
Yeah, and my name is Rich Smith, easier to say than Pepijn's name. I'm the Director of Research and Development at Duo Labs. As I said, my background is much more in security, and my whole career has been in security and mainly finding problems, and now and again fixing them, but mainly finding them. So if the names don't give it away, like we're slightly different sizes. My stilts didn't fit my carry-on, but I'm the little one. And like we say, we're from Duo, so particularly we're in Duo Labs. The nice thing about Duo Labs is we're not tasked to actually make any profit. We just spend the money that the rest of the company makes, and we enjoy to look into a lot of things. We build a lot of internal tools. We build out a lot of prototypes. We do research like this, which isn't necessarily directly relevant to any of our products, just because we feel it helps inform us in the way that we think about the space. As with every other security company in space, we're hiring. But you didn't come here for any of that. We don't really care who we are. You're here to learn about the research. So the TLDR of this whole research was really, we're trying to find ways to shine light onto firmware security. And we were particularly interested in how it compared to software security. Things have got progressively better with software security. There's a lot of mantra around, if you do nothing else, just keep the system patched. You'll be pretty good. And both vendors and users have got significantly better at issuing patches quickly and applying patches quickly. Software security is in a much better state than it's ever been. But that caused us to ask the question, well, what about the firmware? Like, what state is firmware security in? This is field upgradable as well. Updates are a thing, security is a thing. How do these things compare? Is firmware security keeping pace with software security? And so that was one of our kind of big questions that we wanted to dig around and have some answers for. And so with respect to this particular piece of research, how do we do that? And so this is the high-level view of what the next 50 minutes is going to cover. And essentially, we grabbed all of the OS updates and the security updates that Apple have released over the last 3 years or so. So that's covering 10.10, 10.11, 10.12. We ripped out all of the EFI firmwares from them. And we did an analysis over what Apple was shipping in terms of EFI firmware and why, and looking for some discrepancies. And then through Pepijn's contacts in the Mac community, we managed to persuade people to share a bunch of version data with us. We'll go into particularly which versions we were looking for, but really pulling out 3 particular version strings: board ID, build ID on the OS, and EFI firmware version. And then we collided these 2 data sets together. What that allowed us to do was to see the difference between the expected world that we have with EFI that ships with OS updates and the reality of the real world there. You know, is there a discrepancy between the EFI versions that we would expect to be running on particular systems and the EFI that we found running? And we definitely found some discrepancies there as well. So the highest level, this is what we did. We definitely get into some details, but probably a good place to start, because this work got quite a bit of media coverage, and we took pains to try and explain why we focused on Apple. The reason that we focused on Apple's firmware as opposed to EFI firmware in the Wintel side of the world really comes down to the fact that we're lazy researchers. It was a much easier data set for us to analyze. And the reason that it was a much easier data set is because Apple controls that whole stack, as you know, from hardware through firmware into OS and then applications. And for us, when we're trying to get a handle on, is the real world running the firmware that we expect it to, the version of the firmware that we expect it to, if there's that full vertical stack control by one player, that allows our analysis to be much tighter. It's a smaller data set. There's less fuzziness in it. We could absolutely do this kind of analysis for the Wintel world and look at the efficacy of EFI updates there. It just makes our lives harder, and we had to start somewhere. So we weren't ripping on Apple. We actually believe they're doing the best work in commodity EFI security out there. They've built up an incredible firmware security team. Literally the best people in the industry are working for them. And we took pains with the media to kind of point out that we weren't ribbing on Apple and we thought they were doing the best job. Some journalists kind of heard that and relayed it. Other journalists preferred the headline that you know, the sky is falling and Apple is the worst. But from the anecdotal work that we've done on the Wintel side, we can say that the state of Wintel EFI firmware is in a much, much worse spot than Apple's. So worth starting to talk out with that before we start to dive into all the issues that we found. So, things we're going to cover today. We're going to make the assumption that not everybody is super familiar with EFI. It's a little bit of an esoteric part of the system, so we're going to do kind of like a rapid run through of what is EFI and how does it relate to the rest of the system. We're going to do an even more rapid run through of some of the security history around EFI. There's been some fantastic work done in the space, and we are completely standing on the shoulders of giants there. We love the work that's gone on. We're going to give a quick overview of that, just so you've got some names so that you can go off and search and learn from them yourselves. We're going to dig into a little bit about how Apple applies its firmware updates. Different vendors apply them in different ways, so it's good to know how they're working at that. And then once we've got all that context and background out the way, we're going to dig into some of the new work that we did. You know, what did we do, what we found, what we've released to hopefully help things, and then what you can do to help secure your Mac fleets or your personal Mac systems. So, this is a 50-minute talk, but there's like an 80-page research paper, so there's going to be some details that we don't get into here. If you're interested in finding out more, like follow the link, grab the paper, feel free to send questions our way. There's a lot of detail in here. But with that, we can dig in. EFI 101, over to Mr. Bruienne.
Yeah, it only gets more interesting from this point on. So EFI, UEFI real quick. The standard is UEFI. Apple only uses EFI to name it, so we're just going to go with EFI, and we'll drop 25% of it right off the bat. So EFI, what is this thing anyway? It's an acronym, shockingly. Extensible Firmware Interface. And I was trying to come up with an analogy or a metaphor, one of the two, to kind of explain what this actually does. And I was thinking about it a little bit, and then I came up with, it's kind of like a starter motor in a car. Like your car usually doesn't turn over by itself, although some older cars you can actually push and they start, but generally speaking, they need a starter motor for the actual motor to start up. Same with an OS, essentially. EFI is one of the first things that starts up, that sets up all the hardware on the system for later systems like the OS, et cetera, to do interesting things like store data, process content, show you things. In the larger scope, EFI has become the replacement for the older BIOS that IBM first worked out, and then very many other vendors picked up on as well. Goes back to the mid-1970s to give you an idea of like how old BIOS was and kind of why a replacement was needed. And it's everywhere. It is in many systems, including obviously at this point all of Apple's hardware. It dates back to about the mid-90s when Intel started on their own EFI. What was that? At some point, the UEFI standard was standardized. Intel joined them, and Apple started using EFI shortly after the founding of the UEFI Foundation in 2006. So I will not bore you with all the background on UEFI and EFI and why they needed it, but basically all the reasons why BIOS existed to bring up systems for later use was EFI only. It had more extensibility. It was supposed to be forward and backward compatible, basically go with the flow and go with the times and be much more universally useful down the line. Apple started shipping EFI in the first generation of Intel Macs in 2006. They switched away from, as we all know, from the PowerPC platform to Intel, and they needed to use a different firmware because open firmware was no longer a thing they could use because that went with the PPC platform. So they needed to pick something up. Luckily for us, they didn't choose BIOS and gave us all sorts of issues with that. Went with EFI. Initially it was 32-bit on Macs from 10.4 to 10.7, and then in 10.8 they finally switched to 64-bit support. And sort of the standard job of EFI also applies to Macs, so it needs to support basic things like input, output, storage, etc., but as well as some platform-specific things like netboot. Netboot is an EFI function. As well as Internet Restore is another function. I believe in Internet Restore is called Jumpstart in the EFI, and netboot has another name as well. But it's in there so that when you hold down a key, it actually tells EFI we're doing something else. We're not actually booting from another device, and it is invisible to end users. So many of us here and many of our users, or most of our users, will not know this thing is even there. They have no idea. They just know that their computer starts and that's it. And that's the job of EFI, quite obviously. Rich?
So now you know all there is to know about EFI. We're all EFI experts. And so now I'm going to put the black hat on. Why, as an attacker, is EFI interesting to attack? It really comes down to these three areas: stealth, persistence, and access to everything. So from an attacker's perspective, I don't want to be caught. I would like to compromise systems and nobody know I'm there. And if we look at the protection rings on the right-hand side, you'll probably be familiar with ring 3 and ring 0. And the lower down the rings that you go, the more privilege that you have. So your OS and your kernel runs in ring 0. Your application stack runs in ring 3. Ring 1 and 2 aren't used anymore, so just forget that they were ever there. And 3 and 0 are rings that people are very familiar with. Then virtualization happened, hypervisors came along. So people made up a new ring. It's not a real ring, but everyone called it ring -1. That's because it runs beneath the OS. So if you are able to compromise a hypervisor, you can affect anything above it. You compromise the hypervisor, you can affect the kernel, you can affect the applications. EFI runs beneath even the hypervisor. So we say that this runs at ring -2. So you have very, very low level access to the system, which is great. And it helps you maintain these three properties of attack. So as an attacker, I want to be stealthy. I don't want to be caught. If I'm running at the lowest ring on that system, and we'll forget about SMM for a while, but if I'm running at the lowest ring on this slide, let's say, then it's difficult for anything above me to detect that I'm there. If any of those higher layer rings ask me about what's running, I can pretty much lie to it. There are some mechanisms that can be put in place to help detect compromised EFI. Most of those mechanisms aren't really in play, and they're certainly not currently in play in Apple systems. So it's really, really hard to detect if I've compromised an EFI. So that's a great thing for an attacker. That's an attractive attack target. The next layer is, well, if I've got my code in there, if I've compromised the system, if I've compromised the EFI, I kind of want to stay there. Persistence is a good thing. Many other layers of attack, so let's say anything in the hypervisor OS or application layer, if somebody thinks that I'm there or is just super paranoid, they can reinstall their OS, they can yank out the disk and put a new disk in, and kind of dislodge me. And This isn't possible with compromised EFI because you're not really present on the disk. You've actually been flashed into a separate piece of firmware. You're normally in a SPI chip. And so you can toss out the hard drive, replace a new hard drive. My code's still there. My code is still there running at a layer beneath anything that you've just reinstalled. Again, from an attacker perspective, very, very nice characteristic of the target. You know, I'm both hard to detect and very hard to get rid of. And then, you know, as we alluded to with this ring structure, from that very low level, I can pretty much do anything. I can read, write arbitrary sectors of memory and arbitrary sectors of disks. And from there, as my primitives, like, if I can read and write whatever I want, game's over. I can kind of do whatever I want. There are a few caveats, but the thing to realize is if you have compromised at the EFI layer, then your abilities, you know, you've kind of entered God mode. So all of these things make it a very, very attractive attack target. However, with that said, it's really important to point out who are the kind of people that these are attractive attack targets for. Really isn't your script kiddies. It's your well-funded adversaries, and you'll hear people talk about nation states and industrial espionage. So as we're going through a lot of this work, keep it in perspective. You know, the sky isn't falling that, you know, you're going to browse the internet on an unpatched Safari and your EFI is going to get compromised. You know, we're not saying that. However, if you're working for organizations that do have a threat model that includes nation states, or you do have a threat model that includes people that are specifically trying to get maybe proprietary information out of your organization, maybe these are attacks that you need to you know, consider seriously. But not script kiddies. Don't get fooled into this is going to be like a commodity attack. We don't see that happening yet. So we said we're going to do a very brief history of EFI. In previous talks, this was like 5 or 6 slides. We've really squished it down because previous talks have been at hacker conferences and people get more excited about this stuff. So there's like a very brief kind of walk through. The first large or very public use of EFI exploitation was by Snare at Black Hat 12. He had a Thunderbolt adapter where he was able to plug that into a system and essentially use the PCI option ROMs in the Thunderbolt adapter to insert arbitrary code into the EFI. Super cool stuff. He really got the ball rolling. And then slightly out of order, earlier this year, there was a whole bunch of WikiLeaks dumps that got the moniker Vault 7. And there was a tool within there called Sonic Screwdriver. People got very excited about this because it was a low-level nation-state attack tool. Like, cool, you know, we've actually found evidence of one. And I mean, I would not be able to say, but people on the street say it was attributed to the CIA. That would be in line with the kind of people that we would expect to use these tools. And there's also a fairly common consensus that Sonic Screwdriver was really a weaponized version of what Snare had presented at Black Hat. So somebody in the audience, or multiple people in the audience, saw his talk, thought it was really cool, developed a weaponized capability for that, and that went into the toolbox of possibly the CIA, who knows. And then that got leaked this year, but the general belief is that that has been around at least since 2012. It's really difficult for anyone to say for sure. Then Trammell Hudson comes on the scene. Obviously, he gave the keynote here. Everybody is familiar with his awesome work. Thunderstrike 1, very much a progression and building on a lot of the work that Snare had done. Still required a hardware adapter. Still required you physically accessing the system and like jamming something in a socket to do some magic. You know, given that, and then Trammell worked with Zeno and Corey, and so they were like, well, why do we even need hardware? Let's just do it all in software. Thunderstrike 2, some of the most elegant exploit code I have ever seen talked about. This is an incredibly powerful attack. If you're not familiar with it, I couldn't encourage you enough to go, like, Google Thunderstrike 2, watch the talk at DEF CON 23, really, really cool work.
Or Rich, you could just ask Trammell, who's here. He will undoubtedly tell everyone about it.
Do you want the mic? And then, more recently, we get into some of Ulf Frisk's work around PCI DMA attacks. This got a lot of media coverage because the mechanism that he used this PCI DMA attack to extract a 5-op2 key from the disk. Again, allowing you to circumvent full disk encryption because of the way that you can, from a very low level on the system, grab what you want off the disk. Again, really, really cool work. There's more work than we have space to show here. Definitely look up Pedro's work. Again, really, really great stuff. Purpose of this slide, go and look at a bunch of other people's work who've done far more complex stuff than we have. It's incredibly interesting stuff. Over to Mr. Bruienne.
All right. So now that we kind of know how terrible everything is, and we should probably throw our computers away, let's look at how Apple handles all this stuff, because obviously, given that this is sort of a very powerful thing if you can get into it, what has Apple done and what is Apple doing now to keep this up to date and patch it? So we'll kind of look at there's sort of like a watershed moment before 2015 Thunderstrike and after where big changes happened. So we'll look at that and also some new stuff that happened in 10.13. So let's do a quick survey. Who here has done the old style of EFI updates on Macs or had to do them in a institutional setting? Some people, and it was awesome, right? It was a great workflow. Yeah. Not so much. So just to get everyone up to speed, how this worked prior to 2015 is that you had to download an application from Apple that was called Apple or EFI Update. It was an actual application. You had to run it, and it would set all the gears just right for the next time it would boot to actually go into an EFI update. However, you needed to do that all by hand. So you needed to run the application. It would then tell you, all right, now shut it down. Hold down the power key, but don't hold it enough, hold it down short, hold it down long until you hear a beep. Then you can let go. Now don't touch anything or it might break. So yeah, what year is this? This was 2015 again. This was in 2000 or 1995. This was just a few years ago. That's how you had to do that. If you had to do this on an entire fleet, that was quite a pain. For a home user, it's sort of okay, I guess. But if you have to do it to 100, 1,000, hundreds of thousands of endpoints, kind of a pain. So I guess what kind of happened is that people were like, who cares about EFI anyway? It's cool. We don't have to update. Nothing breaks when we don't do it. So we'll just let it go for now, i.e. forever. We'll just never touch it again. So 2015, as we said, Thunderstrike. I guess this is bad, and I guess we should do something about this. So Apple changed the way that they shipped the EFI updates. They no longer made them separate. They made them part of the standard Apple OS and security updates, and it became its own package inside the larger multi-package MPKG. So it became firmware update.pkg, and inside there, it's essentially a payload-free package, so it doesn't actually install anything, but it has a post-install script that calls the EFI update binary, as seen here, and it calls it with a number of specific options to, again, set up an EFI update at the next reboot. However, it would do it in line with an OS updater. So while you're updating the OS, either security or an OS update, it would also inline update the EFI while everything else was going on. So the user no longer had to do it separately. They didn't have to hold down buttons, and you could automate this with your existing tools. The firmware update.pkg ships with an entire set of the current EFI, either capsules or FD bundles. I still need to figure out exactly the difference in format. I know what they are, but it's kind of like hard to explain. So we'll go with, there's sort of the older ones and the newer ones. The older ones are SCAP, the newer ones are FD. And the naming is somewhat easy to follow. It's a model, and then it has a major, minor, .log, .extension. And what ends up happening is that EFI update actually calls bless, and it calls that with a specific number of arguments, and that basically makes it boot next time from the EFI updater instead of the regular boot device. Only it does it inline, and you don't notice that it happens. And when you run that all by hand, the way that the script does it, you get this wonderful output. There's a whole ton of stuff going on here with setting boot volumes and setting NVRAM variables to ultimately get a EFI update to happen at the next boot. You can run this by yourself if you were so inclined, and you can basically see that it won't do anything because it has determined you do not need an update. Hopefully, if it does, it might set it up. So do it in a VM. Do yourself a favor. So integrated into the OS, let's see here, so it's in the bundle package, and it's always included in any update after 2015. It's both in the security updates, OS updates, in the combos as well as the deltas. Now, you would think that they ship the same EFI content for all the different OS versions that Apple still supports, sort of in a soft, support. What do they actually support? So we kind of all know, right, that like Apple seems to support N-1, N-2. So if N is the current, they'll support patches for older versions. But just like they don't necessarily patch every vulnerability in older OSs, they also don't necessarily ship every EFI update in those, and we'll get to that in a minute. So if it fails, if EFI update doesn't get to do what it needs to do, it doesn't really get a chance to run again until the next time OS update runs. You'll see why this can be a problem, because it's kind of a one-shot deal. So we need to talk a little bit about board IDs before we go any further, so that we understand how EFI update makes its determination what actual payload to use. So when we say has a firmware payload, does it have just a million files? Does it have a couple? Like, how does that work? And how does the updater know? And does it possibly live in the EFI update itself? So as you know, Apple uses a number of ways to identify Macs. So they have sort of the higher level way of identifying them by model name and then a sequential number. In this case, I have here iMac 17,1. But they overlap. They don't designate a single model with a single config, and sometimes they reuse them as well as they bump the CPU by a minor amount. They don't actually give them new model IDs, as they call them. So that's not a great way to try to identify them, because that gives you too coarse granularity. So what Apple does is they use a board ID, and the board ID is composed by Mac dash and then an 8 or 16 character hex string. Newer models all are 16 character, older ones are 8. And they are unique for the model and spec. So for example, you'll have the iMac 17,1 here is actually, that family actually has 3 distinct board IDs in there. So one is for the different screen sizes, and then there's another one for a bump that they did at some point that all gave them different, they were functionally different by enough to warrant a different board ID. So this info is not listed anywhere. Apple doesn't have like a handy-dandy lookup chart for this. There's a couple of people in the community that maintain sort of a listing of this. Rich Stroughton has one. He has a gist. There's other folks as well. Depending, the Hackintosh community is also very much interested in this information, because it helps them match hardware specs as well. So how does the firmware updater match this information? Like, how does it figure it out? So it turns out that the EFI bundle actually contains the board IDs that it is compatible with, and it's contained in this lovely GUID right here that I will have a test about later, so remember it. I don't. In EFI, it's a very modular system. There's a lot of modular pieces of code and other things that help it do what it does, and they all use GUIDs to identify themselves, and they use them to denote dependencies as well. So in this case, the GUID listed up here lists the board IDs that it is compatible with. It does not contain the Mac dash part, but it does contain the 16 character or the 16 byte identifier. So what happens is that EFI updater checks the file, the EFI bundle, looks for a specific header, grabs the board IDs, and says, yes, that matches what I'm running on, or no, that doesn't match. Next step. That means that some of them have multiple entries. So that's where the question of does every model have its own payload or not is answered. So some models actually have a single EFI payload that applies to multiple ones. And just to give you an idea of if you're more of a graphical understander or learner, this is a simplified flowchart of how it works. So the EFI updater starts here. You give it a path of EFI firmware update payloads to process. It obtains the board ID of the machine it's currently running on through IO registry, and then it basically just iterates through the files that it got, and it checks to see if the board ID at that particular GUID is a match. If not, iterate again, until we have a match. And that is the actual payload that it uses to blast the disk, and things move on from there. So that's a real whirlwind tour through how EFI Updater knows what Mac it's dealing with and how to assign it a firmware. Rich?
Okay, so we know everything about EFI, everything about EFI's security history, and exactly how Apple updates its EFI. So we're all experts on everything Apple EFI now, which is perfect. And as Pepijn was saying, there really is a very specific match between a particular hardware configuration and the firmware that needs to be running on that EFI. So they're all like a pretty much unique and special snowflake. Which brings us to a lot of our research questions of how are we going to tease this big mess apart from all of these different versions. So if we're starting research, we always want to start with a set of questions, some hypothesis about what we think is happening. And these were some of the main questions that we started with. As I said at the start, we were really interested in kind of comparing and contrasting how vendors provide security support for firmware and compare that to how they support software. So, what state's firmware in? Are all Mac systems treated the same with respect to the security support that their EFI is getting? Are all the different versions of the OS given the same level of EFI security support? As we know, that N-1, N-2 kind of support cycle, whether we'll continue to receive some subset of software patches, or how does that pan out for the firmware side of things? Are they also receiving some of that support? As I alluded to at the very start, we were really interested to compare and contrast how the real world compared to the idealized world from what Apple was actually shipping. And then we had lots of questions around when things might go wrong, how visible is that to a user or to an admin? So these were kind of the questions that we started out our research with, and then we designed a series of analysis to try and answer these questions. So obviously, common update issues that we can find. As Pepijn said, now EFI updates are kind of slipstreamed into the OS, and they're invisible in most ways. So they just work. They magically get applied, and everything's fine. Well, maybe that's not always the case. So we wanted to dig around there and find some of those corner cases. Obviously, I said, the OS support, does it differ across EFI versions? How does the real world match? And how easy is it for end users to actually find out all of this information and see if their EFI is current? So the analysis, we've got this nice flowchart because we realized people didn't necessarily quite understand the way that we were colliding data, and we hope this helps. So our analysis followed two main phases. The first one was to extract all of those firmware updates from the firmware package bundle from every OS update that Apple had released and every security update Apple had released. So we grabbed all of those out, and then we built this data set. And the data set was really triplicates. So OS build number, so we can specifically identify a particular version of the OS. The board ID, as Pepijn said, so we can specifically identify a piece of hardware. And the EFI version, and that's kind of, that EFI will be specific to the combination between that particular piece of hardware and the particular version of the OS that it's running. So we've built up that data set. We do some analysis. With this first phase, the analysis that we did was really looking for anomalies in what Apple was shipping. Were they missing updates for some versions? Were they, for some versions of hardware? Were there discrepancies between the EFI that they were releasing for different branches of the OS? So this was all kind of offline analysis. This was just looking into what Apple had shipped and was there anything strange there. Then phase two happened. We gathered this real-world data, and the data that we gathered in the real world was exactly the same. It's the same data set. We gathered the OS build number from every production system, the board ID of the production system, and the version of EFI that it was running. So we now had two data sets that were comparable, and we did the analysis. We kind of collided these two data sets. And from here, we're not asking about what Apple has released. We're asking about how the real world compares to how Apple would like the real world to be. If everything was working perfectly, these two data sets should match. Big spoiler alert, obviously they don't. And that was where our second phase of analysis came in. And then, from that second phase and the first phase of analysis, we come to a bunch of conclusions. It was profit, but we lost the copyright. So, phase one, I said we're building up a picture of what Apple ships in its OS and security updates. So this is the triplicate that we're looking at, and these are the kind of numbers. So the reason that we have to use OS build number rather than more familiar kind of 10.12.6 is that as soon as a version of the OS goes into being security support and is only receiving security updates, those major, minor, micro numbers stop incrementing. The only way that we can tell the difference between 10.12.6 and 10.12.6 with a security update is by looking at the build number. And we need the specific build number to be able to relate which version of EFI should be running. Like Pepijn already spoke about the board ID, that specifically identifies hardware. Just looking at this number here isn't enough. And then the EFI version, this is just like a long string that says, for this combination between these two things, what is really the build number is the thing that you care about in most cases. It's just this B number at the end. You would expect that B number to increment as new releases of the EFI firmware is released. And this is just how kind of it relates in human language. We built up some big-ass data sets of this, huge tables where we were tracking the combinations between hardware and particular build numbers and what EFI versions that they run. And obviously, we did lots of color coding to try and kind of give ourselves some sanity. You'll see some gaps somewhere in some places, and you'll see distinct differences between versions that are coming out for branches, I say, on 10.12, versions that are coming out for branches on 10.11, for example. So we built all these big data sets, and from this data set of just analyzing the updates, we looked for these kind of anomalies, or found these kind of anomalies. Differences between the support that was being given for different versions of hardware and OS, completely missing updates in some cases, and definitely some anomalies in the way that the versions, even the version numbers were being given. It seems in the build process there's some endianness problems, and sometimes build numbers come out with the wrong endianness. I don't know how that happens, but it definitely did. So the second phase, through Pepijn's contacts in the community, we managed to get those three pieces of version data from 73,000 Macs. Only 54,000 of them actually were running versions of 10.10, 10.11, and 10.12. If you're running a Mac with version less than 10.10, EFI security is the last thing that you need to be worried about. So we just left those aside, and the reason that we focused on these was at the time of our analysis, 10.12 was the most recent version of the OS, and these were the ones that were receiving security support. So now we could do a comparison of things that continue to receive security support from software security support from Apple. How is their firmware security support lining up? And because of this very close tying together of the OS or security update and the EFI that it contained and shipped with, we should have a one-to-one mapping that if you're running this version of firmware with this build number of the OS, or you've run this update, you should absolutely every time always be running this version of the EFI. So coming back to that very first slide where we had the big retro Apple, this is why this data set is very easy for us to analyze, because there's that strong correlation between hardware, version of the OS or patch level, and the particular version of EFI that you're running. And so because of this, once we'd built up this data set of real-world systems of the same triplicate versions, we could compare that data set to the data set that we built up from Apple shipping all the releases that Apple had done, and then we can look for those differences. Here's another way that we were trying to visualize things. Obviously, we were looking at huge data sets, and this data set goes off down into the floor, but we did like some color analysis just to try and help things stand out. The yellow things are the things that are scary on this one, not that you would necessarily know it. So that was how we did it. What the hell did we find?
Yeah, so I guess we already gave it away. There's some things were not the way they should be. So we ran into 4 points here. So real world systems are out of date. Security updates drop EFI model support for unclear reasons. Quite failures, lack of visibility, so there's no real way to know what happened. And also some very weird regressions in EFI update versions. Quick thank you to these folks here. They all, in some way or another, provided us with some chunk of this data. I am not listing everyone's organization because those organizations would get mad. So if you know where they work, happy you. Otherwise, thank you to these people. So first point here, a successful OS update does not necessarily mean you get a successful firmware update. And we did our analysis and we got some percentages in exactly based on the real world data sets, which Model X with OS version Y has an EFI version older than it should be. So we weren't interested in ones that had newer because that may have meant that they were at one point loaded with the current OS and then for whatever reason were backported and they got an older OS because some testing was going on, who knows. But we're not interested in that. We were specifically interested in those that haven't had an EFI older than what it should be. So our overall number is 4.2% out of that 55-ish thousand endpoints had an incorrect EFI version, incorrect meaning older than what it should be. That breaks down a little bit differently in different ways. So the most out-of-date model was the iMac 16,2, so congratulations to that model. You are super out-of-date. And in the same way, OS 10, macOS 10.12 Sierra. Again, at the time we did all this analysis, 10.12 was the latest, 10.13 was not out. So we at some point we need to draw the line. But we're continuing that data analysis as well. So 10% of any endpoint running Sierra was actually out of date. And it kind of varied a little bit. 10.10 was at 3.4 and 10.11 was at 2.1. These are pretty concerning numbers. They're not like out of this world concerning, but definitely concerning. 4.2% out of 55,000 is a good chunk of machines that did not have the right version there. It's a quick slice here, sort of the top of out-of-date models. You can kind of see that there's like a whole chunk of like newer models that seem to have particular out-of-date numbers for some reason in the high 20s and 40s and 30s. And it kind of drops off down there. But there's quite a few newer models as well as some pretty old ones like Mac Mini 3.1 in there as well. Rich, software secure.
So, obviously there were some problems with those updates applying. You were able to update the OS, but the firmware didn't update for some reason. And those numbers were higher than we expected. We expect to see some discrepancies, but they were definitely higher than we were expecting. But you can also be software secure but firmware vulnerable. So what do we mean by this? We said, Apple supports the N-2 versions of the OS and kind of like deprecates that softly. So now we're 10.13, 10.12, 10.11. But they still ship software security updates for those. So you can be running the latest versions of the OS or the latest security patch level, but from our analysis of the EFI versions that Apple was shipping, you're not actually necessarily guaranteed to be running the latest EFI version, even if you're running the latest software version. And the mapping between like which systems do or don't run the latest versions of EFI, even though they're running the latest versions of software, isn't really, it's not straightforward. It's very spotty. So we don't necessarily know why Apple chose to continue to support some systems and give them EFI firmware updates and not others. We can observe that was the case. We can't necessarily infer why. You'll have to ask Apple. But there is definitely a way that you can be completely up-to-date and secure on your software, but your firmware has never been updated by Apple. So what does this kind of look like? Well, these are the bundles that, numbers of bundles in these particular sets. So again, the latest version when we pulled this slide together, 10.12.6. 10.11 was security update 27003, and as was 10.10. So you can see the number of EFI firmware bundles that were contained in each of these. 10.12 or 10.12.6 contains 43 bundles. Security update for LCAP 10, 10.11, 31. Yosemite, just 1. So they're shipping a lot of software fixes, but there's a huge drop-off of the firmware fixes that they're shipping. Again, we can observe the what, it's harder to observe the why. And a patch for one doesn't mean a patch for all. So a lot of those areas of security research that we highlighted early on, Thunderstrike and the DMA attacks and things. Every security vulnerability gets assigned a unique, most security vulnerabilities get assigned a unique CVE number. And these were 4 particularly high impact CVEs that were relevant to EFI. So if you don't patch your EFI, then you're going to be vulnerable to one of these issues. And Thunderstrike 2 really is probably the most impactful one because that can be delivered via software. So what does this look like when we look at the number of systems that do not have an EFI update released for them that protects against these particular vulnerabilities? So in Apple's release notes, they will pull out the CVE and say, hey, we're patching this particular EFI vulnerability, and they don't really list out, we're patching this particular EFI vulnerability for these board IDs running on this version of the OS. They just kind of make a slightly more broad statement. So for each of these vulnerabilities, there was 47 systems, of 47 models of Mac hardware that have never received an update for Thunderstrike 1. 31 for Thunderstrike 2, 25 for this particular CVE, and 22 for this CVE. So this means that even if you are running the latest versions of software, the latest version of the OS, if you're running one of these models, which are specifically detailed out in the paper, will save you the pain of looking through a big table, you will continue to be vulnerable to these vulnerabilities because Apple never released an EFI patch for your hardware. You're going to talk about orphans.
Yeah, EFI orphans, what do we mean by that? So some models seem to have received, they ship from the factory with an EFI version, but then doing the analysis, we noticed that they didn't really get a whole lot of additional updates, if any. So that kind of was denoted by having very low build numbers, so B00, B01, and some of them just never changed or changed very, very slightly, if at all, indicating that they shipped from the factory, but then were kind of like left alone and didn't really get touched. It's unclear why that is. Apple may have very good reasons because they didn't think it was necessary, or they have knowledge of why these machines aren't vulnerable. But it stood out because many other machines do get regular updates. So what we found was that 16 models. By models, we'll mean individual board IDs. We're not receiving any updates after a certain point, so their numbers didn't really. Their build numbers didn't really increase anymore, and about 18 only got factory EFI versions. So they would ship from the factory with, say, usually it's a B00, and they would not get any further patches as well. This is, again, concerning. It doesn't necessarily mean that these models all have unpatched vulnerabilities necessarily, but Apple also has not made any effort to provide any patches for them as well, which is hard to tell from just looking at their documentation. But once you do the data set analysis, that comes out pretty quickly. This is sort of an overview of this is from the paper, so all this information is available in the paper. You can dig into it some more. And you can see here some of these models that we call out that have unchanging or very low build numbers that didn't seem to have been patched very much. The Mac Pro 5.1, I think, stands out there because it had not received any updates for many years until we'll get to in a second. 10.13 came out. So if these updates are silent, if they fail, it's sort of the tree in the forest, and it turns out that silent updates that fail will not be heard. So what that means is that Apple wants it to be silent. They don't want to bother users with, hold down a button or do this or do that, but at the same time, it also does not alert the users or even admins for that matter. There's no way to find whether an EFI update actually succeeded or not. So that makes it very hard to keep track of this if you manage Macs. Hey, I sent this thing out, did the EFI update get installed? No way of knowing in the regular installer logs. And because it's an unknown system to a lot of users, many will not even look for it. They'll just, well, the update went through. I guess I'm good. Apple said there was an EFI update in this software update that I just applied since it didn't break and since it booted up and the number of my OS is now 1 higher. I must be good. So that is an easy, an understandable error to make. And as a result, EFI, as we just saw in our data set, is unfortunately often out of date.
So from some of the offline analysis that we did of the updates that Apple had released, we also found some stuff that was, I guess more funny. It was concerning, but it was still funny. And so we found what looks like some pretty significant regressions. So in the first security update that was shipped of this calendar year, so this is for 10.11 and 10.10, we found what looked like a series of regressions that Apple had just bundled the wrong versions of EFI with their security update. So what had happened was, we can see the numbers here. So this is 2017-001, the security update, and the version string for one particular MacBook Pro from the set of EFI updates. Really the B numbers are all we need to care about. So B17 shipped there. The previous security update, the last security update of 2016, the B number was B18. And then the previous security update to that, it was back to 17. So the first security update of this year really contained the EFI firmware of 2 versions ago for both 10.10 and 10.11. Why this is? I think it's just a QA problem. QA is hard. QA on firmware is, I guess, harder. So, yep, there's definitely a regression. The last time I checked these bundles, the regression hasn't been addressed. It's still there. Luckily, the EFI doesn't actually allow you to roll back your version of firmware. So you wouldn't have been running on B18 and then roll back to B17. The update would just silently fail. But definitely concerning and more of a kind of what the hell, what's going on with QA. Here's another big table just showing that across a number of systems. We checked the hashes. It's exactly the same version that's shipping.
We had this confirmed as well, that this was an actual oops.
And as I say, we can't downgrade our firmware, so at least there's that. So we've talked about a lot of problems. What are the mitigations? And we're definitely out of time, and Ed's given us the evil eye.
We'll go faster. How can we fix it? You can't. Everyone go home. No, you can't. So that's InfoSec. We tell you what's wrong, and then we tell you to go, figure it out. We don't do that. We try to give you some things to do. So obviously, a big fix you can do here is just upgrade to 10.13 because 10.13 is awesome, right? Yes, is it great? Yeah, maybe. You can do some logging and reporting to, as you do with other systems, to keep track of what's actually going on. You can run the updates out of band, should you desire. Apple will tell you don't do that. I say, well, you can at least try it. And then Apple is also addressing some things in 10.13. So updating to 10.13, why is that an option? Well, first of all, you need it for APFS. APFS requires EFI support, so you must update to a newer EFI. The Mac Pro Tower models actually got an EFI update. There was much rejoicing. If you've done these, you notice that it goes back to the old model of you must update your firmware. Please click this button, hold down the power button until you hear a beep. I think this is the last time we'll hear about this. Just a heads up, it's going to do that. You're going to want to do that. Otherwise, those Mac Pros will not be able to boot. In fact, Apple actually started shipping these EFI updates that give you APFS support in 10.12.5. They kind of, I guess, saw that this one-shot deal was not a great model and things may not grow so well. So they decided to start sort of preloading Macs with this APFS support so that if your 10.13 update somehow botches the EFI update, you're not locked out because now your disk is APFS, but your EFI low-level support does not know how to handle it. So a smart one by them to do that. And then we'll talk about EFI check a little bit as well. You can do some of your own checks. So if you use OS Query, Puppet, Chef, or even a shell script, here are some examples of things you can run. Our good friend Victor Vrenchen, who is at Collide, wrote a great blog post about how to use OS Query to get this information, so definitely go check that out. He writes into much greater detail about that. And then you can also use EFI Updater to kick it back off. You can apply them out of band, so if you have a Mac that has an older EFI, you can just reapply the same security or OS update again. It will not really break anything. It will just give EFI another shot to be installed. Use the combo updater. I think that's sort of like best practice. If you're going to reinstall something, use the combo updater. It gives you the best shot, at not breaking anything. You can also create a standalone firmware updater. The Imager project, the wiki has some entries on how to do that, why you might want to do that. Again, Apple does not recommend this, but it has worked for a lot of folks. Real quick, 10.13 has some new tools. There's a new tool called EFI check. It does not deal with version discrepancies. It only deals with EFI integrity. It attempts to check the checksums of the EFI running and alert you if something is wrong with it. Sino Kova, who since his work with Thunderstrike and many other things has started working for Apple and is working on EFI actually, had a tweet storm that got removed because you can't really do that. But anyway, I took one, the starting one of that, because he kind of wanted to explain why you might see this somewhat not great UX-y dialogue that says, your computer has detected a potential problem. That sounds legit, right? That sounds super legit, like we will trust that immediately, especially you, Thomas. That would be great, right? Anyway, this is actually an Apple thing, mostly surrounded by Apple privacy, kind of having to ask you before they ship anything off. So this system is trying to use whitelists to detect firmware modifications. I'll leave it up to smarter people than me to decide whether that's actually a viable system and whether you can spoof this. I think we can say probably, but it's a good effort by Apple to stay on the forefront of making sure that EFI is actually what it should be. So great effort by them. UX is not great yet. Hopefully it will get a little better. Let's see. We got some tools, real quick. This is the good stuff.
Some tools, yeah. So we didn't want to just leave people hanging with lots of problems. We tried to give them a hand as well. So we released some tools. We've called them Effigy. I can't take any credit for that. The smart name was all Pepijn. Really is just about giving you a very easy way to see, are you running the expected version of EFI, and for the particular version of EFI that you're running, are there some other problems associated with it? So we've released it, it's open source, it really comes in two parts. Client's open source, the back end is just like a pretty simple API. Probably worth saying, currently we're only supporting 10.10 through 10.12. The data for 10.13 is going to drop soon. That's all my fault. I've been too busy traveling around at other conferences to actually do my day job. So there's a Cli app that has wonderful textual output. You can grab that from Effigy.io. That's the GitHub project. There's now a GUI app, literally as of today. So one of the other researchers on the team, James Barkley, released a nice GUI so that it's more pretty when you can run it on your Mac. And also gave us a GIF, so he's one-upped my static Cli screenshot. And then an intern on our team built a web app so that you can, if you go to API-effigy.io, you'll find this web app, and it allows you just to do a very simple one-shot, put in the strings that you find, and it will tell you, are you running the expected version of EFI or not. Grab it all from this repo. We did say demo, but we're way over time, so find us afterwards, and we can show you things working. And conclusions. So very quick fire set of conclusions. We found a lot of weird things, and it took us probably start to finish from when we like embarked on this work to actually getting to a set of conclusions. We probably spent a good 3 months.
Yeah, 3-4.
So if we spent 2 full-time researchers who get paid to do this kind of thing, if it took us 3 months to actually just dig through, find the data, and be able to answer some of these pretty straightforward questions that we had, that for me feels wrong. As a vendor, I would encourage any vendor, and certainly Apple, given this is an Apple conference, to be really transparent. If you're releasing a security update for something, be clear about what you're releasing it for. If you're not releasing a security update for something, let people know that that security update is not being released so they can make a mindful decision of, do they want to accept that risk, or do they want to compensate for it in a different way? Keeping it buried in the depths of the system, as is currently the case, really doesn't aid anybody, and it's going to take people like us months of time to tease this all apart. So if nothing else, transparency is key. Please, as vendors, tell people what you're patching, give them the knowledge that they need to evaluate their own risk. Obviously, it's very clear that systems can certainly be software secure, but firmware vulnerable. Big takeaway, firmware, and certainly EFI, to all intents and purposes, EFI is a full operating system. It meets all of the criteria that an operating system needs. So it needs to be treated like an operating system. It needs to be patched diligently, and that's both from a user perspective, making sure those patches are applied, and also a vendor perspective, making sure those patches are released. So if it looks like an OS, treat it like an OS. Your firmware security can undermine all of the higher levels of security that you're spending many hours kind of securing your systems against. Certainly not all hardware will be treated equally. These things are often unique and special snowflakes. You take an EFI from one system, apply it to another, it's not going to be a happy day. So make sure that if you're seeing activity on one type of hardware, that actually maps across all of the other hardware. You may find different things. QA is hard. Shipping regressions is easy, I guess. And if you're looking into firmware, like making sure that you are doing the same level of QA and diligence that you apply to your software. As I said, EFI is definitely like a full OS. And just to underline, like the last point, we really do believe Apple is actually taking EFI security very, very seriously. EFI check coming into 10.13 is a great example of that. Making good steps forward, lots of space to improve, but they're doing a good job. So some links, there's a paper that goes into way more detail, a blog post that is some high-level overview, and then all of those effigy tools. We've got some updates that hopefully we'll release today or tomorrow to allow kind of batch mode for across whole fleets via JSON input files. So those updates will be coming, so look out for them. Certainly can. Photo opportunity time. But yeah, thank you for coming and listening. Apologies for running 10 minutes over. And yeah, thank you. It's been a pleasure.
Thank you, you two. No, the 10 minutes over was no problem. It was a good 10 minutes over, right? Everyone was captivated, I think. And I think on behalf of everyone, thank you for the open source tools. That means a lot. And I think especially in, yeah.